I've explained Ram.
So OLTP is a data warehouse management system where we are storing the fast, sort as well as day-to-day related transactions, where we need to use, insert, update, delete uh, keywords, and it's also using for lesser amount of data, and it is uh, the example like Micro-partitioning server, PostgreSQL, as well as Oracle DB, and MariaDB. That's the example.
Tell about what is OLTP and OLAP.
The online transaction process that is deal with the day-to-day transaction. Where is a OLAP is an analytical process. It is deal with the historical and analytical and reporting purpose.
Volume package.
It is it deals with the day-to-day transactions OLTP. The OLAP deals with the historic and structure, summarized summarized data.
Okay.
It supports OLTP supports DML operations and OLAP supports select statements.
Okay. So see here, OLTP is for day-to-day activities. Like suppose we go to bank, we withdraw, we will deposit, use Google Pay, so Phone Pay. So immediately we going to get like message, right? Our balance, what is the created, what is the debited. So those details we need to check for every second. So those we can handle with the OLTP system, like with the Oracle SQL Server, some other databases, okay, on-premises database. We can handle the PostgreSQL, right? So we can handle those data. So but OLAP for analytical processing, okay, we need to give after 1 month, 1 month or 2 months, it depends. Suppose I'm selling one laptop, okay, so this is March 31st financial year ending, okay, so I need to provide those details, okay? Those details uh, like in April or May. So before those days, maybe like 3-6 months before, I'm getting the project. So they are 19 data from Oracle to Snowflake. Then in the Snowflake, we are doing the analytics, okay, and we are applying the business logic. So that we need to present in the May month, like that. What is the sales, okay, profit? What is the features? Why it is reviews? So what we need to develop those things. That is those things analytical, like completely data processing. We use the OLAP. So see, Oracle, we can't maintain large data. So we don't like managing like hard disk. Okay. So need employees. Okay. Need physical requirement. We need to install, okay, those things in the OLAP systems. But come to OLAP, so everything done by the Snowflake and Redshift and BigQuery. So those are OLAP systems. Okay. So those are OLAP systems. Okay. So now OLTP for Oracle day-to-day activities. OLAP for we need to give after 2 months. That is OLAP Snowflake example. Redshift BigQuery. Okay. So why they going to ask about, okay, is Snowflake is OLTP or OLAP? So you need to go with OLAP. They will ask full form online transaction processing. They will ask the OLAP full form online analytical processing. Okay, these things they will ask. Okay, so just go with these notes. Okay, here you can see OLAP stands for online transaction processing. Okay, designed for day-to-day activities. OLTP. Okay, OLTP stands for online transaction processing. It is a design for day-to-day transaction operations like orders, inserts, updates, and deletes. Think of your banking app, e-commerce checkout. Okay, those run OLTP systems. They are highly normalized. Okay, so we're going to receive data, denormalized data first. First, we're going to have the denormalized tables. So denormalized means suppose one single file when we are receiving. So that file going to have the employee details, department details, HR details, some other sales details, maybe some other details. But here for employee, we need to get separate table, department separate table, HR separate table, okay, and sales separate table we need to create. if everything is combined, that is we need to call denormalized. So after loading the data, we need to normalize. So we need to create separate tables for customers, HR, for department. Okay, for sales, we need to separate tables. Okay, so usually the data is normalized. They are highly normalized in the OLT system. So handle high concurrency and optimize for fast row level reads and writes. Okay, these things. Next, go to OLAP. Okay, just so OLAP for like analytical processing is the opposite. Okay, opposite, complete opposite to the OLTP. Okay, it is built for reading. Okay, and analyzing large volumes of historical data. Okay, so we are talking about data. So whereas like Snowflake, Redshift, BigQuery, and they are denormalized optimized data. So we're going to receive first denormalized data. So for after that we're going to make normalization. Okay, OLTP normalization. So OLAP denormalized data. After that we're going to normalize the data. Okay, then for complex aggregations and chains like across like billions of rows, we're going to do with the for analytical processing in the OLAP systems. Remember examples: OLTP, Oracle, SQL Server, PostgreSQL. But OLAP, SnowSQL, Redshift, BigQuery. So why Snowflake? We have big Redshift, BigQuery, right? So Snowflake having like it's going to have three cloud providers: AWS, Azure, GCP. Okay, but Redshift, BigQuery having only one. Okay, and if you want to scalability, high scalability in the Snowflake, within 1 second we can increase the warehouse size. But come to the Redshift, BigQuery, it will take some time, maybe 2 hours, 24 hours, 48 hours. Okay, so it will take time. And we have special features like data replication, zero copy cloning, so we can access the historical data if any data is deleted. Those things using time feed, these we have. Okay, these things we can handle in the OLAP system. So that's why Snowflake is best now. Every company, so every people, they are moving to their work to the Snowflake. So in our project, the source system were OLTP. Okay, transaction data from Oracle and second and transaction data from Oracle and SQL Server, and we ingested that into Snowflake, which is our OLAP layer for analytics and reporting. Okay, so these things we need to handle. Okay, so remember OLTP, OLAP. Okay, so mostly if you attended 5 interviews you go to attend, so in that one time you're going to face this question, not every time, one time. If you go with 10 interviews, 3 times you're going to get it. These things. Okay, so next move to explain star schema, Snowflake schema. So explain, Rahul.
So star schema is a centralized form of data design model where dimension table is directly linked with central table, which is known as fact tables, which stores factual data in terms of numerical form, numeric data types and all. And the descriptive data is like it's contextualize the data, factual data. Like if you have a fact table where all the order ID, product ID, a transaction ID, and all is mentioned. But in dimension table there will be like product description, product category, order date, and all those things. So that will contextualize or describe the factual data. And star schema is a data design model where we are having facts fact table. Then we have fact table is associated with dimension table, and dimension table is associated with sub-dimension table. So it's a layered kind of a storage. So yeah, that's it.
So Sesha.
Yes, task schema is central fact table, central fact dimension table connected with the fact tables. Like it is in design can easily understand compared to Snowflake schema, and also like it adds fewer jams to run the query. It requires only fewer jams to perform the query performance, and also like it has the redundant data due to denormalization table. and also like prepared in Snowflake for the large for the improving the query performance. When it comes to Snowflake schema, it is normalized version of the star schema. It requires more joins, and also like it is used in the like dimension table to split the multiple tables.
Okay. Mamata, స్టార్ స్కీమ్ స్నోఫ్లేక్ స్కీమ్ మీకు తెలిసింది చెప్పండి. సో మీరు చెప్పండి. ఓకే.
Yeah, star schema is like it is used for faster queries and it is simple design and it is uh, it is surrounded by fact table plus denormalized dimension tables, and Snowflake schema is used for slightly for slower queries. And the Snowflake schema is a normalized dimension. So it can be split into multiple tables, and it saves storage in Snowflake schema.
Okay. So here we have star scheme and snowflake scheme. Okay. So this is a data modeling concept. Data modeling. So like when we are learning about star scheme or snowflake, we need to know about data warehouse concepts like what is data warehouse, data mart, data lake. Okay. So modeling. So when we have data in the S3, so the architect going to discuss with the admin, okay, what is the approach or star schema or snowflake schema approach. So if the approach is like star schema, why? If approach is snowflake, why? You need to explain. Okay, but in curated layer, so we follow the star schema. Why means it's going to fast. The code is going to run fast. We can save the cost and we can save the time, and there are multiple reporting team going to work, dashboards going to run. So it is good for dashboards, for reporting. When we are sharing data with the reporting team, it is good for reporting, good for reporting. Then why snowflake? So when there are complex logic, okay, joins, complex joins, so more metless weaves, in that scenario we will apply the snowflake schema. So most of the time we're going to apply the star schema. Star schema is in between. Okay, here we're going to have one fact table. Okay, one fact table. This is going to have only numeric data. Suppose we have patient table, doctor table, instance table, hospital table. Okay, so patient ID, doctor ID, okay, hospital ID, and instance ID. Okay, or branch, hospital branch number. So instance ID. So this going to have in the fact table, numeric data. Okay, so after that in dimension tables. So in dimension tables. Okay, in dimension tables. Okay, here we have, right. So patient ID we going to have in the dimension table. Patient ID, patient name. Okay, so patient, what is the CAS? Okay, like why, what is the reason, health issue. Okay, those details we going to have in the patient table. Okay, it is having both numeric data, description. Okay, again doctor table, doctor ID, doctor name. So those other description data we going to have again in the instance ID. So what is the company name, instance company name, those details. And again we have one more table. Which one? Hospital table, hospital branch name, branch. Okay, where is located, city name.
Address,
Okay,
yeah.
branch name, where is located. So what are those here? Okay, so remember in fact table we're going to have the numeric data, so which is connected with the primary keys of each dimension table. Okay, primary key column we're going to have in the fact. So remaining those dimension table having the like description data. So with all numeric and description data. Okay, so this is for look like star, right? In between we have this star one table and it's look like star. That's why they use it to call the star schema. Okay, so then snowflake schema. So again fact numeric, same like IDs. Again dimension tables. Okay. After that, we have subdimension tables. Subdimension tables we have here. Subdimension. Here, these subdimension table going to connect with dimension tables. Okay, dimension tables. These subdimension are going to connect with dim subdimension tables. Okay, these dimension table, subdimension table. Okay, think like fact like grant for the dimension parent and subdimension child. Okay, so you can't find these things parent father child. Just I'm explaining to understand. Okay, so these we have grant task, parent task, child task, but not for this. Just image like that. Okay, grand parent child, these things. So in this subdimension table we're going to have the date columns, date, okay, times, date, those things, okay, purchase date. Okay, so those attributes we're going to have in this subdimension table. Okay, so here fact connect to dimension and dimension connect to the subdimension. So subdimensional data that the primary key we're going to have in this dimension table. So dimensional primary key we're going to have in the fact table. So that's why. So it is dimension connected with fact and the subdimension connected with the dimension. Then automatically subdimension connected with the fact table. Okay, this is Snowflake schema. Okay, so Snowflake schema, fact, dimension, subdimension. These things we're going to have. Okay, so now interview. What is a data model? What is a modeling concept? Okay, what is your approach? Okay, what your in your project you follow the modeling concept. Which modeling you have done? Modeling or which schema you applied? Which schema or which model? So schema means star schema, Snowflake schema. Which model means star schema and Snowflake schema. And they will ask data. What is the data modeling? Followed in the previous project. Okay, so what is explained? Okay, we need to tell this one. So major why a star, why Snowflake means next we need to explain. Okay, so difference star, fact, dimension, fact and dimension. Snowflake, fact, dimension, subdimensions, and these things. Okay, here star schema denormalized. Okay, and Snowflake schema denormalized and normalized, both. Both. Okay, star schema has only one central fact table surrounded by denormalized dimension tables. It looks like a star because the dimensions are not normalized, not normalized. Then again, and here we're going to follow simpler with fewer chains, and it gives better query performance. We use it. So most often in data marts. Data marts. Okay. So data mart is subset of data warehouse. Okay. Snowflake schema is normalized version for star schema. Okay. So where dimension tables are further broken down into subdimension. For example, date dimension might. Okay. So split into year, month, day tables. This reduces redundancy and storage, but requires more joins. Okay, which can slow queries.
Slow query in start schema.
Yeah, slow. Yeah, the query is going to run slow in this Snowflake schema, but we can join multiple joins we can have. But in star schema, fewer joins, so it's going to give fast performance, going to faster. But in Snowflake schema, so more joins, that's is going to run slow queries.
Running query complexity.
Yeah.
Yeah.
Okay.
Because
So they will ask most about what is the difference between star schema and Snowflake schema. So you need to explain. Okay. So in my project, we primarily use star schema in our reporting layer. Okay. So because our end users needed fast dashboard performance, I explained, right? And the denormalization trade-off was acceptable at our data value. See here, and the denormalization trade-off was acceptable at our data value. They're going to ask it to accept denormalized data also, but we're going to have usually normalized data only. Okay, so this is star schema and Snowflake schema. Then go with what is data mart. So, Koti, tell about data mart. What you know?
Data mart is a subset of database. So performance and access.
Okay.
Goes down particular departments like sales, HR,
So data mart is a subset of data warehouse, which is taking care of specialized tasks in our organization. Like we are having HR department, sales department, marketing, and other departments. So we will bifurcate the data to data marts, and it will help the reduce the data volume.
Okay. So Shesha.
The data mart is a subset of data warehouse, contains like sales and financial and marketing data. Marketing improves quality performance by reducing the data volume, and also like it helps for business users quickly finding the relevant data.
So your data mart, okay, subset of data warehouse. So we're going to have business function data like sales, finance, and HR. Okay. So it is for smaller, for faster queries. Okay. So it is going to give direct to teams, business teams, direct access to the data they need without going through the entire warehouse. They need the data, so no need to. We are loading data into the warehouse, then we are doing the transformations, delete and duplicate, then finally we are applying the business logic. So they don't have that much time. So they need direct access to the data. So they use it without going through the entire warehouse. Okay. So we had a sales data mart and a finance data mart in our project. The sales team only queried their mart, they didn't to touch the full enterprise warehouse. It improved performance, also gave us so better across control. So immediately they need direct, the business people going to have the direct access to the data mart. So business teams direct access to the data they need without going through the entire warehouse. This in the data mart, remember. So remember like sales and finance and HR. So these data. Okay. So what is the data lake? So data lake is like the S3 bucket is a data lake. Okay, S3 bucket.
Like the storage of
Yeah.
structure and semi-structured data.
We can have like we can store structured CSV files, semi-structured JSON, Parquet, Avaro. Then we can store unstructured data, images, files, okay, videos.
Yeah. Use volume of data.
One S3 bucket contain 5 dB data, 5 dB data. So, but it can have more than 5 TB, that not good. Okay, it will difficult to handle the 6 TB data, but maximum it can hold 5 TB data. One S3 bucket. Okay, so in Snowflake going to support structured CSV files, semi-structured JSON files, and unstructured directly we can't access, but we can access only metadata of those files, metadata files. So, but they use it to tell like it going to support for unstructured data. Okay, but not really. Exactly, we can't load image or video file, but we can access those metadata when we have in the cloud or S3, Azure Blob Storage, and GCS. When you have data in S3, Azure Blob Storage, and GCP, GCS. GCP is to relate to GCS, is related to the GCP. Okay, we can access the metadata. This thing. Okay, example S3, Azure Blob Storage, GCS. So and check if any some others there. Okay, so you can go with this theory. So not that much they won't force you to ask in the about data lake. Okay, just tell I know it is a S3 the data lake, and so if you have more experience like more than 5 years, 6 years, more than 6 years, then we go with depth about what is S3 look like, what is the schema is applied when you are into the data. So these things you can check. Okay, so data warehouses you already know, centralized. Okay, repository. There is only 1 minute region with the same link. Region with the same link. వీటిలో పెట్టుకోండి. So data mart, data lake, fine, right? And then go with what is data warehouse here. So is my screen is visible to you? So what is data warehouse here? It is centralized, okay, structured, okay, repository optimized, okay,
For data storage.
For reporting and analytics. Okay, and it stores historical integrated Okay, subject oriented and time variant data. Snowflake is the cloud data warehouse. We use it for schema, and write data is cleaned, transformed, and loaded into schema before storage. Okay, these ensures high data quality and fast query performance. Okay, in our architecture, S3 was the data lake, Snowflake was the data warehouse, and on the top of Snowflake, we had Power BI for visualization. So these things we need to go with. Okay, remember, okay, data warehouse centralized repository. Okay, so it is optimized for the reporting and analytics, stores historical and integrated, subject oriented and time variant data. Snowflake is cloud data warehouse. So we use follows schema or write data is cleaned, transformed and loaded into the defined schema before storage. This what is the meaning of it? It allows schema on write data is cleaned, transformed, and loaded into defined schema before storage. This is high data quality and fast performance. Means okay, clear, right? So the clear, right? This point it follows schema and write data is cleaned, transformed, and loaded into a defined schema before storage. So this is in the high data quality and fast query performance. When before schema means before start schema, so it going to loaded and we doing the cleaning and transformations. Okay, example Snowflake, BigQuery, Redshift. Snowflake, Redshift, BigQuery. Okay, these Redshift and BigQuery so competitor of the Snowflake. Okay, remember that. Okay, so example we can tell warehouse concept. Okay, this thing. Then we move to next one. Okay, so what is a confirmed dimension? Suppose I have one table, instance details. So in the details, same table I going to have in table environment. Okay, same table, same table, same data, same table I'm going to have in the test environment. Same table I'm going to have the some other environment. So a confirmed dimension is a dimension that is shared across multiple fact tables. So data marts with the same definition of value. For example, a date dimension, a customer dimension, used in the both sales fact table and the finance fact table. The benefit is consistency. If I define customer the same way across sales and finance, I can drill across both marts, get accurate cross-functional reports. In our project data, date and customer were confirmed dimension shared across all our data marts. All our data mart means so I have in the customer table. So it is related to the fact table of sales fact table. Okay, so I have the customer table is related to the same finance fact table. Okay, so same one table confirmed dimension means same table we're going to have in one schema, same table we're going to have in another schema. Okay, so this is the confirmed dimension. Okay, so what is a confidential dimension? Is the high level abstract dimension used doing the design phase of data model. It represents a business concept like time, geography, product before it's physically implemented. Okay, it's a part of conceptual modeling where you identify what dimension exists at a business level before you get into the logical and physical design. Once you move to logical design, it becomes a proper dimension table with the attributes and keys. To be honest, in a day-to-day project work, we deal more with logical and physical dimension, but concept dimension are important in the initial design workshop with the business stakeholders. When I'm going to receive data from the stakeholders, from client stakeholder, we're going to receive data, right? So they're going to have these conceptual dimension. Okay, so where you identify the dimension exist at a business level before you get into the logical and physical design. So before the design, so we're going to have the one idea about the data. So that is like about time, geography, product, these things. It is a conceptual dimension. So phase of when we are doing the data modeling. So before it represents a business concept like time, geography, product before it physically implemented. Before implementing, we're going to have a one dimension that is a conceptual dimension. Okay. So self introduction.
Yeah.
Self intro.
SMS, sir?
Yes.
Yeah, so hello, my name is Rahul Kumar, and I have over 5 years of experience in Snowflake data engineering, where I was handling the multiple data project in healthcare and banking related domain, where I have used the Snowflake Cloud Platform uh, and DBT tool to handle a large volume of data. Yeah, so that's it.
నెక్స్ట్ దీపా మీరు చెప్తారా అండి? దీపా
Hello.
సెల్ఫ్ ఇంట్రో చెప్తారా అండి?
Yes, myself, I'm Padmaja Deepthi. I have overall 6 years of experience, within that 3 years as a data engineer. And recently I worked for NatWest. Here we migrated data from Oracle GMS system to Snowflake. And initially we loaded data into Snowflake using copy activity, and then we handled the data from Kafka as well. I set up the Snowpipe on top of AWS S3 and loaded the data into raw, and then we followed the star schema model, and after the ingestion we performed the raw to source to target reconciliation and prepared the documentation accordingly. And yeah, this is
ఓకే. శేషానందం చెప్పు.
Myself, Shweta, I have totally 4.5 years of experience as a Snowflake developer. My key skills are Snowflake, Snowpipe, AWS, and DBT. And I have done my recent project in Carless Data in Snowflake Cloud Solutions, where I was responsible for data migration and real-time data verification and data warehouse optimization. When it comes to roles and responsibilities, like currently our source system is Oracle, where each team load data from S3, load data to S3, from where as a Snowflake developer I load data from S3 to Snowflake. For that I am using storage integration, and I also giving the ARN authentication. I will load ARN authentication as per business logic. I have created the streams to track the changes on the table, and I also used Snowflake for the continuous data loading. And I also used copy for the data comes in bulk scenario. I used bulk copy into that's it.
Yeah, hi, this is Kodishwar Rao. I have around 13 years of experience in IT. And I'm working as a data engineer with experience in Snowflake and Azure and the ETL pipelines. I have hands-on experience in building data pipelines using Snowflake and optimizing queries and handling large-scale data. I worked on end-to-end data solutions, including addition data from S3 to Snowflake and transformation reporting. And also I have experience in performance tuning and handling real-time challenges.
Okay, so I will give the intro, so you can follow that. Okay? So hi, thanks for considering my application. So my full name is Bushyam Palamaria. So working as a Snowflake developer, so as a 6 years overall my career as a developer. So in IT field, I have overall 16 years of experience on Snowflake developer, 6 years complete data engineering, and with DBT last 2 years I'm working with DBT. So my skill set is like Snowflake, DBT, SQL, and S3 services, and AD block storage and GCS, and with Airflow on Python. Okay, and Snowflake Cortex AI. This is my technical skills. Okay, so I have done data migration project. So this is my like short intro about myself. Okay, next they will ask about the project explanations, next roles and responsibilities, next challenges. So one by one we need to go. First, what do you do, how to put into clear the intent. So first go with the recording, second we go with the questions, third we go with the mock interviews and practice, 4th week apply. It's going to close within 4 to 5 weeks. Okay, follow these steps. Don't hurry, worry. You're going to miss the companies. So many persons, okay, many students, so with the resume, not now, so previously also. So stick with the plan. Okay, so remaining will continue in the evening. Okay, remaining will continue in the evening as per or tomorrow or evening. Okay, so now you people go and have the lunch. We'll come back. 3. No, don't come. Okay, almost 3, right? Having trees. So tomorrow morning, try to come 10 a.m. here. Be at 10 a.m. మీరు కూడా 10 a.m. కున్నాను. Station 10.
Like class is over at 9:15 and it's fine.
Come 10 o'clock. 8:15 to 9:15. Sometimes delay. Morning time, right? Having these things. Okay. So మీరు మళ్ళీ రేపు మార్నింగ్ 10 రండి. ఓకేనా? So okay. Thank you for joining. So